Well, I think a lot about the future of industry, and that's what the current new book is about. How do we not think about robots as replacements for workers, but think of them as complements to workers? Again, that's a lot more out there than it was 10 years ago.
Welcome to Becoming Radical, the podcast for creators, builders, and dreamers just like you. What does it mean to become radical in a world of constant change? Hosted by Michael Gaizutis, each week we'll explore the real-time journeys of those rewriting the rules. From untold failures to groundbreaking success. If you're ready to break the boundaries of limited thinking, this is your guide to unlimited growth.
Welcome to Becoming Radical. We're excited to be here with everybody again today. We are lucky and privileged to be joined by David Mindell, who is a technologist, historian, and entrepreneur working at the intersection of robotics, human-machine collaboration, and the future of work. David, it is so great to have you here. Really appreciate your time today.
Thanks. Happy to be here.
Yeah. And I'm so sorry you're under the weather. I know how that goes. I'm getting over something myself. So it means a lot for you to be here with us.
Yeah, just got a little cold.
Absolutely. So, we were talking just for a couple of minutes before we pressed the record button here about how you're the co-founder and chairman of Humatics, which is, for everybody here listening, it seems to be a pioneering company that's developing spatial intelligence systems. Do I have that right?
That's correct. Yeah, we do very high precision navigation for robots and other kinds of vehicles.
That's exciting. What got you into that space specifically? I know you've been a professor at MIT for over 2 decades. I'm assuming there's some kind of crossover there with that relationship.
Yeah, I started my career doing robotics in the very deepest parts of the ocean, down in a place
Oh,
called Woods Hole, which is not too far from here in Boston. And I joined the group that found the Titanic just a couple of years after they found it, and
wow.
spent the next 20 years or so building and operating robots with my colleagues down there, exploring shipwrecks and hydrothermal vents in the very deepest parts of the ocean. Really
Wow.
interesting, exciting work, and that spawned a bunch of things in my career, but one of them was navigation was always the hardest problem we faced underwater. Like, where are you?
Right.
GPS really doesn't work at all. And I built sonar-based navigation systems down there that did very high precision navigation for those robots around shipwrecks and other places that we wanted to map with great precision. But
Wow.
I always wanted to do that kind of same technology in air in places that people could use it in factories and other more familiar environments. So
Wow.
instead of sonar, we switched to radar, and
Hmm.
Humatics is sort of a radar company that makes, think about it as millimeter accurate GPS for indoor environments for factories and robots and other people to understand where they are in relationship to each other. Started that company just about 10 years ago, actually.
Hmm.
Ran it for 6 years, and then, when I stepped aside as CEO, stayed as chairman,
Hmm.
um, co-founded my new company, which is called Unless, with a partner, and we are investing in uh, companies that are transforming U.S. industry in this critical moment.
That's fantastic. Very exciting. Talk to me a little bit, if you can, about what those industries are that you're investing into. They're transforming industries because obviously we all have our own ideas of what that could look like. But understanding more of your subspecialty, your thesis, if you will, for investment, what that looks like.
Sure. So, less than 1% of venture capital in this country goes into industrial companies,
Right.
and yet coming out of the pandemic, disruptions in global supply chains from
Mm.
other global events, the need to address climate change,
Yeah.
the current tariff situation.
Yeah.
Um, we're all in a place where actually both parties in Washington agree we need to revitalize U.S. industry for a number of different reasons.
Of course.
And we've really turned our backs on the kind of make it with our hands part of industrial development in the last 30 years.
Sure.
And we're not going to address climate change without making a whole lot of new stuff, and
Yeah.
um, and we need to reinvest in the systems that we have. So uh, unless we focus on companies that are bringing new technology to transform industrial systems.
Right.
And that could be energy, could be mobility, could be food
Right.
supply.
Yep.
Um, uh, but all of these giant invisible systems that provide the things that we live on,
Mm.
which again, they're only kind of visible when they become disruptive and we can't get enough toilet paper or whatever.
Yeah.
But they're very visible, and it's clear that we're in a period of rather sustained and repeated crisis. Whether
Mm.
it's one thing or another, you know, we all need to be resilient to crisis in the coming decades or so. And
100%. Yeah.
and you know, and yet we have not really invested in a lot of that industrial infrastructure. It's been very slow to adopt new technology.
Mhm.
Um, and that, energy is of course a big part of that. We need to change our energy system. And most of Silicon Valley is really still set up for software companies and
Yeah.
SaaS platforms and
Yep.
things, which are important, but they have very different
Yeah.
life cycles from what an industrial company does.
They do. They do. Absolutely 100%. This is where I am. I'm in the Bay, Silicon Valley area. Super familiar. Been here since 2007, pre-iPhone. I remember was an early iPhone adopter, got the iPhone from a hardware software perspective. People were there was just this magic in the air here. But you're absolutely right. It's very much software dependent. It's very much focused on now every sign you see went from Web3 to AI. It's lesser focused on the tactical, the robotic space, by and large, as you talked about. And I guess that's a question for you, going backwards a little bit. What was the original inspiration for Humatics, behind Humatics? What problem initially were you trying to solve for in market?
Well, so after I left Woods Hole, I came to MIT, although I did both in parallel for a long time. And I realized that when we were working in those extreme environments with robots, we had learned a lot of things that maybe 10 years before they were going to get learned in driverless cars or even in factory robotics.
Yeah.
And space flight, aviation, the military, all these extreme environments have been forced to adopt robots, in some
Yeah.
cases, decades before. And so that became a lot of the subject of my research at MIT. It was a book I wrote in 2015 called Our Robots Ourselves. I wrote
Mm.
another book about the lunar landings and how
Wow.
people and machines work together, and what it takes to make machines and people work together in very complex environments with
Mm.
lots of, you know, uh, interesting software and various forms of autonomy.
Yeah.
And that felt very different from the way that autonomy was being sold back then, which
Mm.
was, I'm going to make this little kind of fuzzy little vehicle and it's going to go off and do everything on its own. I'm never going to see it again. And it's just like,
Right.
your little R2D2.
Oh
And
yeah.
very few, in fact, really know that I had looked at real autonomous systems work that way. They always work when they have very rich collaborations between
Hmm.
people and machines. And if you
Absolutely.
just look at the space program, when they first introduced a computer on the Apollo lunar lander, everybody was like, "Oh no, the computer can't land the ship. The people have to land the ship." And what happened over the course of
Yep.
that project was they developed a lunar landing system that was, because it had a digital computer in it, it was actually less automated. The Soviet spacecraft had analog computers in them. They were very rigid,
Mm.
very highly automated, left very little room for the cosmonauts to have input. The
Mm.
American actually had very early digital computers. Some of the first integrated circuits were used in the Apollo program. And that software enabled the programmers to write collaborative code that made the lunar lander really a true collaborative robot where the crew and the automation and the folks in Houston on the ground work together, in a really rich, interesting way to get those landings done. And they tried 6 landings in the Apollo program and they succeeded 6 times. So it's hard to
Wow.
argue with that success.
Yeah.
And Humatics was really founded. It's the first 4 letters of human and the last 4 letters of robotics to use this precision navigation idea as the glue that holds integrated systems together. And when I say integrated systems, I really mean three things: people, robots, and infrastructure. And in a
Mm.
factory or in a warehouse, a lot of other settings, those are the three things you really have to have working together. That's the overall robot you care about, is the people plus the robots plus the
Hmm.
infrastructure that you try to design. I,
Makes
I
sense.
once said I once said to Jeff Bezos, yeah, the whole warehouse is like a big giant collaborative robot that way. And
Yeah.
he said, exactly. Actually, we think about the whole supply chain as a big collaborative robot, which is
Mm.
right. And so um, the more you have that framework, you see everywhere these rich collaborations with people, robots, and infrastructure. And then you can ask, what technologies do we need to make that work well?
100%. How do you define spatial intelligence, and why do you think it's such a critical foundation for the future of robotics as we know it?
Well, in 10 years, we'll look back and you can say, gee, you remember back in the 20s, we didn't know where anything is.
Mm.
We've gotten used to GPS, which works
Ah,
pretty well
yeah.
when you're outdoors and you can see the sky. But
Yes.
most people and most robots spend most of their time indoors.
Right.
And the indoor location problem is a pretty tough problem. Um, some robots solve it with lasers and cameras. We
Mm.
solve it with our sort of GPS type system, which is very, very precise. And um, think about every millimeter in the space around you should have a digital tag to it.
Mm.
And you should be able to know about what's going on in that space, what's around it, what's been happening in that space. We're not in that world yet. As digital as our world is, it's
Right.
still really confined to, laptop screens and data centers.
Absolutely. Yeah. And it sounds to me like it's really a micro location technology different from a GPS or traditional positioning system. Would you say that's correct with Humatics as a primary focus?
That's correct. I mean,
Yeah.
the idea is very similar to GPS in some ways,
Yeah.
but again, GPS works outdoors. It's accurate to, maybe a meter or so.
Yep.
Um, and, we ended up finding a market with subway trains because they go underground. And when they go
Right.
underground, they're very hard to
Mm.
track. And we also uh, are able to track robots in industrial settings with such high precision that can really
Sure.
start to do new kinds of things that are very hard for them to do before.
Makes sense. You've written extensively from what we understand and what I understand about the need for human machine teaming. What are we, you think, still getting wrong in the way we think about autonomy today?
Well, I think it has evolved in the last 10 years since I wrote the book, which I'm happy about. At the
Yeah.
same time, there still is this sense that, somehow there's this ideal of full autonomy and we're like going to, you know, push this thing out in the world and then it goes and goes and goes. And
Right.
that I think is a real myth for a couple of
Yeah.
reasons. First of all, every robot is made by people, right? So there's human intention
Yep.
built into the architecture, built into the software, built into which sensors are chosen depending on the task and the
Yep.
environment. And as much AI as we will be putting in them, AI is also a very human-based technology. It aggregates human
Yes.
behavior in unique ways. And
Yep.
so the idea that they're somehow separate from us is unfounded. And and there again, the times that they work best are the times where they are in this rich interaction. And if you look at driving was the hot thing back in 2015, it's still kind of
Yeah.
hot.
Yep.
Um, and you look at how humans drive, we don't just drive by following a map or even by avoiding
Mm.
collisions. It's 1,000 little social contracts you have where you see the person on the corner, you make eye contact with them, you decide are they going to cross the street or not,
Absolutely.
and you understand the ball game just got out and there's a huge crowd. It's going to
Mm.
be slower.
Yep.
Um, there's a lot around you that gets brought in, and even here in Cambridge, people drive differently in Central Square than they do in Kendall Square, and they're only a half a
Yeah.
mile away from each other.
That's right.
So,
Yeah.
uh, what does it mean for an autonomous system to be
Mm.
kind of deeply embedded in that environment? And I think that the car companies working on that stuff have gotten better about it over the
Yeah.
years from their initial fantasies of sort of just going on their own.
Yeah.
People used to say to me, "Do you think Waymo changed their approach because they read your book? Because Waymo has changed their approach." And I used to talk a lot to the guy who headed Waymo about this,
Oh,
and he
wow.
disagreed with me vehemently. And
Mm.
I said, "No, I don't. I don't think my book convinced them. I think the real world changed their mind.
Yeah, the
All
world
my
is
all
yeah,
my all my book did was describe the constraints that the real world places on autonomy,
makes
and
sense.
they probably could have saved $1 billion if they'd read it more carefully." But
Hindsight, looking back, right? It's incredible to think once you put something in application, especially in this case with Waymo, let's say, with autonomous vehicles, which we see all over San Francisco, of course, all over big cities. And obviously they're still having problem sets, extensive problem sets, but looking at the learning of the real world application coupled with what you've contextualized in your book, you're right. I think money could have been saved and better served if we could have just given that a little bit more grace and opportunity to think about what that could look like. I think there are a lot of promising use cases with collaborative robotics in industrial or mobility sectors. What do you see as some of those most promising use cases right now?
well, I think a lot about the future of industry, and that's what the current new book is about.
Yeah.
And how do we not think about robots as replacements for workers, but think of them as complements to workers? Again,
Yes.
that's a lot more out there than it was 10 years ago. I'm happy about that.
Yeah.
Although it's still not so easy to pull it off.
Yeah.
Um, how do we deploy technology to augment human capability rather than
Mm.
replace it? Um, and we did this whole project on the future of work since then, which is very much incorporated into the
Mhm.
new book. And you know, very few of these technologies contain the social relationships within them.
Mm.
They're often get determined at the moment of application, often by a low level or a mid level manager.
Yeah. Yeah.
We've seen numerically controlled machine tools deployed in ways that are de-skilling of machinists, and there's
Mm.
other companies that employ them in ways that are very augmenting of the machinists. So there's a lot of nuance to how things get rolled out. We're
Mm.
at this point now with AI where we have a lot of choices about, we have to make a lot of choices about how it gets developed and how it gets deployed. And there are now people asking, what does a worker friendly AI look like? How do we create AI in ways that respect what humans have to bring to the table
Yep.
in work settings, which is a great deal that often engineers don't see because we don't train them very well to see
Mm.
the labor that is involved. Where
Absolutely.
is the intelligence? Everywhere you look around you, there's intelligence embedded in your environment. Um, there's a great line from one of my favorite cognitive scientists, Don Norman, says, the world remembers things for us just by being there.
Mm.
And so think about even just the architecture of your house is a sort of memory that guides you around what you need to get done during the day. And
Absolutely.
relieves you of having to do a lot of things that you don't have to worry about, so you can focus on
Right.
doing the things that are important to you.
It's a great line. That makes total sense. How do you think companies can design tech systems that do respect, as you said, human judgment while still leveraging the power, the possibility of automation?
Well, for one thing, you know, a lot of the technologies, a lot of these decisions get designed by young engineers who are not
Yeah.
very often very well trained. Again, to see the labor that's around them and
Mm.
to recognize the intelligence and the dignity of that labor and how much people often know about their jobs.
Yeah.
Um, and um, you know, it's very fashionable in the driving world to talk about, oh, drivers make all these mistakes, and
Mm.
that's true. But actually, drivers correct a lot more mistakes than they make.
Yeah.
It's a lot easier to measure the mistakes that people make rather than the mistakes people avoid. But as
Right.
humans, we're
True.
very, very good at like fixing all the rough edges. And
Mm.
I've studied this with airline pilots, and it's a little
Fascinating.
easier to study with airline pilots where you'd think that we'd be able to make an automated airliner. Flying an
Mm.
airliner is actually much easier than driving a car in some ways. You
Right.
don't have all these crazy pedestrians crowding around you, and we
Exactly.
still don't do that because the systems are just fragile enough, and the people really are the glue that hold them together. They
Mm,
talk to each other, they see each other. There are many, many cases, including, Tesla's experience when they first put the Model 3 factory together, of
yeah.
way too many robots. And Elon Musk said at the time, we over automated and we
Mm,
underestimated the power of what people bring, and
that's right.
they had to back off on it, and they put people back on the production line.
Yeah.
So, by no means should we not be using the best technology we have,
Yes.
and at the same time, we always want to look for the places that people have something to contribute, which is quite a lot.
Makes sense. I think we're seeing that in AI as well. Big companies like Klarna, for instance, over thought the AI spectrum with, reducing human capacity right now in today's day and age, and then saw a major pushback with a lot of failing touch points in their customer journey. And now they're bringing humans back in, right? Because they're realizing that the efficiency and inefficiency component are not equal to one another at this point. They're not equally weighted, right? So you're absolutely right. I mean, I think we see this in robotics, we see this in AI, we see this in a lot of different applications. Yeah, I remember hearing a story. I can't remember the exact details. You would probably remember this better than me, but I believe it could have been World War II. It might have been World War II, where the army was seeing planes come back that had bullet holes in the planes, and they were trying to figure out what was going wrong. And I think from memory, they realized that eventually they were studying the wrong thing to figure out the solution to the problem. They were studying the planes that came back, I believe, versus the ones that didn't, or it was the other way around. There was some story around that I read, and I thought it was fascinating. I don't know if you recall that story too,
Yeah,
but
yeah,
there,
that was a story of where,
yeah,
you know, if you plotted out where all the bullet holes were on the planes that came
exactly.
back,
Yes,
that's not where you want to put the armor,
exactly. That was it.
because
Yes,
if they got a hole in that spot, they got back. It's the
exactly. That was
places
it.
that no planes came back with holes with them.
That's
That's
it.
where you put the armor, because the planes that got a hole there never came back.
That's exactly
And
right. It's a fascinating story.
that's sort of a story about data in some level.
Yeah,
But
yeah,
World War II is a very rich time for experimenting and pushing the limits of human machine collaboration in
extremely.
aviation and a lot of other places. And I've studied that for a long time as well.
Yeah,
And uh, so there are interesting examples that we can look at.
yeah.
Aviation is a great example. There are companies all over that are also doing this really well, and there are also companies that are screwing it up. And so
Right.
we just want to be conscious about the companies that are doing it well. And uh, for engineers, I work at a giant engineering school. We train a few thousand engineers every year and send them out
Wow.
there. It's crucial that we teach them to understand who are the users, what is the environment the machine is going to go into,
Absolutely.
what do the people there already know. Whereas for a young 22-year-old engineer, it's like, oh, I've learned all this at MIT. I don't need to
Oh
talk to
yeah.
anybody who works in
Yeah.
a factory. And there's some value to that kind of fresh approach,
Yeah.
but it also leads down a lot of stray paths.
Agreed. 100%. You don't know what you don't know, and it doesn't hurt to go into the nuances of what has been done, what's being done. It's incredible what you learn in that 20-year span. You learn a lot. So, and you're still learning every day. So, thinking about your transition coming from the academic side to co-founding a venture-backed company, what was that transition like for you? For our listeners, that's a big transition point. What did that look like?
Yeah, so I started Humatics when I was 48,
Okay.
and
Yep.
I had had a very successful academic career. I was a chaired, tenured professor,
Wow.
um, which is a very comfortable life if you want it to be
Absolutely.
that way.
Yeah.
And then I sort of like started again and made myself extremely uncomfortable.
Yeah.
Now, to be fair, when I was 25, I had two goals in life. One was to get a PhD, and one was to start a company. And I
Mm,
kind of fell into being a professor. That was actually not one of my goals. So this
interesting.
goal of starting the company had never left me. And I was really inspired by Steve Jobs, like in his
Mm,
first incarnation at Apple in the
yeah.
70s when they first made Apple.
Yeah.
And So I had been planning to start this company for 20 years and
Wow.
kind of laying the groundwork. I always did a lot of consulting. I always liked working in industry. I had
Sure.
licensed two inventions off to other companies and worked with them to develop it. Um,
Wow.
and all that said, consulting is radically different from starting a company and dealing with the
100%.
finance and the law and the
Mm.
employment aspects of it all. And, I'm amazed looking back at how little I knew about it in some way. But
Yeah.
I also was humble enough to gather people around me who could help, who knew things that I didn't know.
Yes.
And
Yes.
uh, and there, obviously there are a lot of individual operating lessons about how a company has to evolve. We did our Series A, and all of the 7 employees who were there before that said, "Oh, now I get my own department. Here's my proposal for the 30 people I'm gonna hire." We say,
Mhm.
"Actually, no, that's not really how it works. We're gonna
Yeah.
go out and hire the people who are the senior leaders now, and you may end
Right.
up working for one of them. Just because you were earliest doesn't mean you're,
That's
you know,
right.
you're some people were, but and,
Mhm.
and how the people that you need changes radically over the course of a company's life cycle.
Yes.
And there are certain characters who are very suitable for that, very early stage, and there's a lot of fun to be had there. And then as it grows and stabilizes, that's one of the reasons I stepped aside as CEO. We needed a leader who was much more systematic and commercially
Mm.
oriented than I was.
That makes
Uh,
sense.
and and the statistics are that when founders step aside voluntarily, the companies overall do much better than when the founders are forced out. So I didn't want to wait for that day.
Absolutely.
Um,
Yes. That's
and
all
there's
true.
there's too many lessons to count at some level.
Yeah.
Um, uh, but those are all things that now, as a investor, I spend my days sharing with founders and other, leaders in the startups that we invest in, or even ones that we don't invest in. And
Sure. Yeah. Well, those life lessons, those business lessons, that entrepreneurial spirit, I think really helps to supercharge those conversations and those strategies. Having the experience that as a consultant, academic background, and moving that into commercialization and market, all those things provide a level of deep empathy and tactfulness to enable these entrepreneurs and founders to really build and co-build the right ventures. So I think it's phenomenal to have that background, not just coming from Wall Street, the hedge fund place, where everybody's like in billions, and they're trading and shorting positions and doing quant, so I think having that background and understanding the volatility as an entrepreneur is a big thing. It really helps. So if we think about lessons you've learned when it relates to commercializing deep tech, specifically in an emerging field like robotics, what lessons have you learned around that?
Oh, that's an interesting one. I think, I'm a little disappointed with robotics. I don't think it's done very
Yeah,
well in the last 10
yeah,
years. And
yeah,
some of that is the adoption problem. People are still fairly hesitant to adopt robots. Some of it is
yeah.
the systems themselves. Um, I'm supposed to speak at a robotics venture conference here next week, and
Wow.
you know, and I there's a few ways that I crystallize it. One is I
Yeah.
see a lot of robots that are really great point solutions for one problem, right?
Yes. Yep.
And that's the right approach engineering wise is to solve a particular problem really, really well.
Mm,
But that's not really an investable company in most cases because,
right.
okay, you're going to weld this kind of seam better than the next guy, right? That's a pretty modest market size, but it needs to
Yeah.
be done.
Yeah.
And so, and and then you have the adoption problem, which the way U.S. industry is structured these days, almost all of these companies depend on uptake from larger, more established companies. And those people who are working in those companies did not get there by taking risks and being scrappy. And, they're the opposite end of the worker spectrum from the people in the startups. And
Right.
how do you get them to take risks and do new things is very, very hard.
Yeah.
So, we don't really do. I actually say in my book, in the new book, the new Lunar Society book, um, I don't like the term tough tech because I've yet to see any tech that's not tough, right? Um, and we don't really do deep tech in the sense that we actually like to invest in technologies that are ready to scale
Mm,
industrially,
makes sense. Yeah,
because that's actually the hard part. The early stage part, a lot of people cover. We're very good at it. MIT is very good at it.
yeah, of course.
We know how to make radical new things. What we're very poor at is scaling them into an industrial scale, and
Mm,
we don't finance that well, and that's really what we do now.
that makes sense. Yeah.
Uh,
What do you think the world of robotics and automation will look like 5 to 10 years out? If we were to project out, what do you think that will look like, and how do you think Humatics, going back, will fit into that vision? Namely, as you move forward.
well, I think I'm prepared for the idea that there is a moment when all of a sudden it'll seem like robots start popping up everywhere. Like
Mm,
we'll cross some usability threshold and then it'll
yeah.
kind of break free. I'm not sure we're in
Mhm.
that moment yet. I
Yeah.
don't see um, there's a lot of hype about humanoid robots. Show me one humanoid robot working in a factory for 5 years, then you can begin to talk about scaling. Show me
Exactly.
1,000 working for 5
Yeah.
years, then you can begin talking about scale. At the moment, I've
100%.
seen 0, right? And, we don't really even know what kind of data collect to train those models that those
Mm,
robots are gonna need. There are people working on that. We have some irons in that fire, but, um, so I do hope that you see a much more kind of fluid collaboration of robots and humans environments instead of the kind of awkward, clunky things we see today. But that's hard,
yes.
if you create a robot to do something useful, it has to move fast and pick up heavy loads.
Right.
And when it moves fast and picks up heavy loads, that means it's dangerous. It can hurt people.
Mm,
And you're into a whole new realm, different realm of engineering. And those are really tough problems to solve in an elegant way.
absolutely. Yeah, it always goes back to the clips of Boston Dynamics robots, doing the rounds, the flips, the dances, the heavy lifting, and then it extends out to what Tesla's trying to do. Of course, as you said, and the level of intelligence and the intersection of how do you manage and co-manage what's coming as we get into that dangerous territory of they can do too much or they could do too much. So you're absolutely right. And I think it's a whole nother field of understanding how innovation does remain human centered, but also ethically grounded. And how do you think we ensure that happens with AI and robotics evolving rapidly with that, ethically grounded approach around human centered innovation with AI and robotics?
Yeah, well, so again, the new book, which is called The New Lunar Society, is really about that specific question.
Yeah.
How do we talk about the future of industry without being utopian, um, and being realistic and grounded, and at the same time being hopeful and optimistic? And I think that's very possible, right?
Yeah.
Um, and again, I actually have a set of rules at the end for doing that. Um,
Mm,
again, see the intelligence at all levels of an organization. Understand all of the human work that goes into creating these technologies.
mhm,
Um, don't talk in flashy innovation speak. Talk
mm,
about particular technologies solving particular problems. And
right.
at MIT, we often use the idea of process innovation.
Mm,
Think as much about process innovation as product innovation. We're very good in this country at product innovation. We've really dropped the ball on process innovation, and that's really where
right.
the important stuff happens.
Yeah.
And we need to swing our pendulum back toward young people working on process innovation, which is a very interesting, gratifying place to be.
Yeah.
Uh, Instead of just the flashy new thing, the yellow colored robot that barks like a dog. Great, but that's not process innovation. That's a product that nobody's asked for.
Exactly. Exactly. No, 100%. You know, if I'm a young technologist or founder or, somebody who's getting into industry and I really want to work at the intersection of engineering, ethics, entrepreneurship, as you've done, as you're talking to many doing, what advice would you give to somebody listening in today, tuning in, hearing you? if you could give a piece of advice or several pieces of advice, what would you leave behind with them?
Well, there again, I would say, um, you know, get excited about maintenance and repair. Um,
Hmm.
work on process innovation. The really important innovations often come from people who really know how a system works and runs.
Mm,
Um, you know, I maintained high voltage lines for 20 years, and there's this one thing that's really missing, right? Those are very
right.
important people.
Of course.
Um, uh, and building things in the world is humbling, but a good
Hmm.
source of humility and really something that we need right now.
Yeah.
And when I see the big hyperscalers or Facebook and they lay off a
Mm,
thousand people, I'm sorry for them. That's no fun, but I'm
yeah.
eager to think about those thousand people going into other aspects of the economy where we really
Yeah.
need people working right now. And so I
Absolutely.
think manufacturing is a very important way of building the world and changing the world and affecting social change. Again, the new book is really about how manufacturing and industrial work in general is a source of social change. You
Mm,
don't have to be on the streets protesting or writing letters. Like, many manufacturers have really changed the world. And those are all places we need young people going right now.
wonderful. It's great advice. This has been a remarkable conversation, understanding your background, what you're doing today, who you're working with, life lessons, business lessons, use cases, advice for those listening in. We really appreciate you being here. Where can everybody find you, uh, David, as it relates to social? We talked about your book a little bit. How can they learn more about you, your firm, what you're investing into? Anything else you'd like to share today?
Sure. So the new book's called The New Lunar Society, An Enlightenment Guide to the Next Industrial Revolution. That's just easily accessible on Amazon.
Mhm.
Um, the the investment firm's called Unless, and so unless.co is the website there. You can learn a lot more about that. And then probably just easiest to Google me, in that I have like hundreds of hour-long talks that I've given, or YouTube things that we've done over the years. So
Wonderful. Wonderful. Well, for everybody tuning in, this will all be in the show notes. We appreciate and value your time. We'll be following you. You're definitely becoming radical. You're on your way to building more things with more people, and now investing in those businesses are equally radical. So, again, thank you for being here today. We'll be following you every step of the way and hope to have you back again in the future to share more of the stories that you've impacted and the builders and entrepreneurs you've supported.
thanks. I've been radical for a very long time, and
Yes.
the book is about a bunch of steampunks in the 18th century who really changed the world.
It's amazing. We're gonna follow it. We're gonna read it and enjoy it. Thank you so much again for being here, David. And we'll talk again soon.
Great, thanks.
Thank you.
Thank you for listening to Becoming Radical. If today's episode sparked something in you, follow wherever you listen, join the conversation, and share it with someone ready to think beyond limits. Be unlimited, be bold, and become radical. See you next time.
Game over.